This is one of those discoveries that's going to be hard to believe, especially with my use of Claude, but I'm confident that I found the math that fills in the gaps, shows the texture of the hidden energy in all empty space, showing subtle properties of boundary layers from the atom to the cosmos. I'll give a brief intro, then show you the math that holds it together. Intuitively, after the Big Bang, you'd expect vortices in a substrate rotating at the speed of light frictionlessly, forming protected topologies surrounded by counter-rotating layers in the shear zones. Instead of a vacuum, there's a lightweight vortex left behind when the heavier matter rolled up, filling all empty space. I give it the nickname DC1, dark carbon. Like other particles, it is made from vortex cores, each of which has an uncountable number of vortex lines. Mass is the rotational energy that leaks out past the counter-rotating layers that form to hold it in. Fermions are unbalanced, so they shed mass, and bosons are balanced. And the photon is a dipole vortex, a MOND in the substrate. The proton is a Borromean knot of 3 interlocked vortices where colors come from the phases of the interlock and flavors from braids. And spin shows the double wrap because the electron has an extra layer twisted into its protected knot. From these assumptions, the backbone equations fall out of existing physics. The speed of light is the vortex rotational speed. Energy is the mass times the speed squared when fully expressed as kinetic energy. That's plain physics. And the quantum potential is the reaction force of the counter-rotating boundary layers using superfluid mutual friction. The photon is the MOND, those boundary layers wrapped into a dipole vortex. So an atom compresses by emitting one and then expands by catching it. And 2 opposing balanced layers collapse into 2 opposite balanced free vortices that can only be stopped by the antiparticle or caught by another atom's boundary. They support varying energy levels in the same envelope, just like a MOND. The equations predict what you'd expect, the standard model plus some specific precise matches like the mass ratio of the folded electron, the muon, and the energy of the vacuum, a match to the MOND scale, and that gravity moves at the speed of light. They also help explain a number of puzzles of the cosmos, all from a consistent set of equations that don't require an alternate reality. So these vortex cores are rotating too fast to be seen as individual particles. Instead, they're modeled as topologically protected vortex lines that bounce against the core and against the enclosing envelope, or they nest into the eddies with an antiphase pair. And the Compton wavelength shows that lighter disturbances have longer ripples because it takes more leaking mass to draw the tight containment envelope. Zooming out, each lattice cell's remaining leak is held in this honeycomb, another balancing cushion of another invisible boundary. So you can see why a lightweight vacuum particle, balanced in antiphase pairs, wrapped in an envelope, nested in the honeycomb, it leaks no measurable mass. And an energetic superfluid with its vortices at the medium speed adds no visible signature to anything that moves through it. So let's turn to the math. I'll walk through the derivation of the quantum potential, Planck's constant as a property of the substrate. I'll show the famous mass-energy relationship and then the math behind the large lattice size that bridges particle physics with cosmology. And then finally I'll show the picture of gravity that unwarps space-time. So the HVBK mutual friction formula provides the reaction force metric for the superfluid. And Simeonov found the right math to express the Schrödinger equation with 2 fluids, one carrying the bulk energy flow and the other the inertial response of the osmotic motion. So fluid 2 has an osmotic velocity modeled with this diffusion constant from the mutual friction. And this is the counter-rotating boundary that responds to the changes in fluid 1 with leaking pressure. And Semyonov's derivation, these two fluids show the Bohm quantum potential as the reaction force held in that boundary layer. And notice how Planck's constant sits inside the diffusion constant. So the same constant that holds the boundary layer energy is also the energy packet size for the photon, which is the modon. So Planck's constant is the discrete minimum vortex circulation for the substrate, using the HV-BK's dissipative friction and the quantized circulation. And this paints a clear picture of what mass really means, as these layers of hidden vortex energy that diffuse out behind an aperture of counter-rotating layers. And the mass relation is where you can see that inner layer. The effective mass is energy including the hidden spin, where the value alpha mf is the aperture, the fraction that leaks out that we measure. So the effective mass only shows with like a probe strong enough to break through that inner layer. And different layers have different apertures because the electron is a single vortex, so it's enclosed by a single toroidal vortex counter layer. This gives it a narrow aperture that lets out under 1/3 of its spin as visible mass, so it appears light. The proton's knot holds 3 vortices in opposition, a 3D object that cannot be wrapped by a single toroidal vortex. So it takes many seams to close it, and each one leaks that same fraction. So this creates a much wider aperture that makes the proton appear heavier. This picture of mass also explains the mass defect, why a bound nucleus weighs less than its parts, along with covalent bonds as like boundary merging. And the benzene ring shows this toroidal vortex where it merges more boundaries between those atoms. And merged boundaries are lighter because they leak less. And look carefully at how the effective mass carries the rotational energy and lands right at E equals mc squared. So with vortices rotating at the speed of light with their kinetic energy tightly wrapped. Bolovic found this formula that shows the coherence envelope size in superfluid helium as related to the medium speed. So when you use the speed of light instead, it's the Compton wavelength formula for the vacuum particle as well, and it comes straight from Planck's constant. There are a few steps to finding the lattice size. So first I'll show why the substrate has the acoustic metric, the one Bolovic found. Then the equation that gives the rough lattice size from the dark matter density and the geometric formula that corrects it. And then finally the condensation number that fits that size from particle physics. Bolovic observed the acoustic metric Lorentz invariance, which is of sound propagating in superfluid helium, He3. And this is the substrate's mirror with the same antiphase vortex pairs. As the weakest unbalanced atom, it doesn't freeze near absolute zero, and it follows the energy patterns of the substrate just at a much slower speed. So we use the same equations with the speed of light, and we expect a much higher condensation number because the particles are so much lighter, it's going to need a bigger envelope. So that length chi comes from 2 directions at once. Bolovic's formula for the coherence envelope used with the observed dark matter density of the universe, then reduced to a count of particles, each with a mass. Then the close packing, self-binding nature of the superfluid allowed no space in between. So using 1 DC1 per lattice cell to start, we find the lattice size at 111.8 micrometers. But the binding energy of the substrate means that DC1 cells overlap each other, which makes that size an overestimate. So the geometric prediction shows that DC1 cells overlap, and the lattice cells, so the accurate size is 97 micrometers. And in that geometric prediction, each factor has a physical reason. So the 4 pi is the solid angle that gravity needs, And the 1 over square root of 2 is the healing ratio of the antiphase cores in the condensate. And the 1 over K is the Bessel zero from the photon-modon structure. And close packing of the substrate shows that we don't need to correct this for like 3D. And by combining the quantum circulation with the quantum frequency, the mass term drops out, and it shows that same 4 pi term used with the speed of light squared as this kind of energy shape for the substrate. And that's the same 4 pi in the cell occupancy that also we're going to use in gravity. So in superfluid condensates, the condensation number is the population size that organizes as a larger cell. So for He3, it's on the order of 1 million, and here it's 1,000 times larger. And that's explained by the lightweight, balanced antiphase partners leaking very little mass, and so needing this really large envelope before the counter-rotating boundaries have enough energy to form. And although the condensation number was tuned to the lattice size, that same value supports these other predictions and the broader picture on lightfluid.org. So in the substrate model, gravity starts as an ebbing leak through these stiff boundaries, but then accelerates in between. So the free fall of a DC1 particle gives the radial inflow velocity as VEV of r as the square root of 2 gm over r. And so you take that term and you plug that in to the Speta-Volovic acoustic metric, and this gives the standard equation for gravity. But here it shows clearly that the pressure effects explain black holes and gravitational lensing and the adjustments to atomic clocks. So I hope that from seeing these equations, you're at least curious whether there might be a substrate of vortices rotating at the speed of light that underlies everything. To me, it unravels the mysteries of the quantum potential, finds the hidden vacuum energy, paints a clear picture of how the universe began and more. And if you're like me, you'll get stuck on that condensation number of 1 billion. It's like a huge lift from the particle physics scale up to like the size of a human cell. And it's the hardest concept to grasp, but it's also an essential one. And it's why the lattice is so hard to see. With that 100 micrometer scale, the 16 micrometer sheets and then an 8 micrometer counter-rotating layer in between is what really offers the deepest insights, where this gives you a common ratio, the square root of 2 between the two pairs and the power of 2 between the sheets. And chemistry can use those ratios to lock onto the energy of the lattice. It can avoid it, or it can like pivot against it. And so this ends up becoming an energetic texture that we can use to unlock a deeper understanding of boundary layers, like at all scales. So see lightfluid.org for the paper. It goes into the math in more detail. There's a narrative that walks through the broader picture at a high level. And then there's a curated AI explorations I use to solidify these results that find a lot of predictions. So let me know what you think, and thanks for watching.